Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be a review and solution set for the TINC Challenge number 4 in our Cisco Learning Labs curriculum. And so let's go ahead and take a quick look here at the scenario that we're dealing with. So Challenge 4, it's the first troubleshooting at TINC Garbage Disposal Limited. We are assisting customer engineer Donovan, and there are a few network issues. So during maintenance of Gateway 1, the customer realized that Gateway 2 does not serve as the backup to the internet. And so here are the two gateway routers. If we were to take a look at the job aids, it'll give us a better visual. We can see the interface assignments here, Ethernet 00 between Gateway 1 and Gateway 2. The connections out, Ethernet 01, and then Ethernet 03 brings them down into the distribution layer. We can see the VLAN setup, and then we take a look at the routing setup. And so we can see here that the internet service provider is, it looks like we are multi-home to the same provider. BGP Autonomous System number 65535, and BGP ASN 65000 is our BGP AS. So we're having some sort of a problem with Gateway 2 when Gateway 1 goes out of service. So let's pull Gateway 1 up, and let's also pull up Gateway 2, and let's take a look at what could be going on here. So let's go in from user exec to privilege exec, and let's simply take a look at the log. Let's see if the log is giving us any additional information here. And it looks like basically the router has booted up. Our BGP adjacency is up, and the OSPF adjacency is up. And let's come over to Gateway 2. And we're not on Gateway 2 for too long here before we see that we have some sort of an issue. I did not realize it was going to be as pronounced as this, or as straightforward as this. So we can see here that we're getting quite a few indicators, and I will snapshot that indicator right there, BGP, right? So we've got the facility is BGP, the severity level of the syslog message is going to be severity level 4 warning. Whoops, I'm sorry, it went by there. Severity level 3 is what we're looking at. And the mnemonic is it's a notification. It's not severity level notification, right? Because remember, severity level notification is severity level 5, right? When we're talking about 3, we've got error. Okay, so warning is 4, error is 3, and so what does it say? It says peer, and the peer would be, I don't believe we're running iBGP between Gateway 1 and Gateway 2. Let's take a look here. Let's go from user exec to privilege exec and say show run. And not include, but let's take a look at section BGP. And so here is, and we are running iBGP, and so we can see from the BGP config here that our AS is configured properly, the AS with our peer is configured properly. However, it appears that we have 65335 instead of, and let's double check that, it should be 65. Yes. So it should be 65535 for the neighbor statement with the internet router to which we are peering. So let's get into global config here. Whoops. Let me shut this down real quick. All right. So let's get into global config, and you can see peer in the wrong AS, right? So clearly something wrong. And the 2 byte, it shows the 2 bytes as FFFF coming through in terms of the 2 byte autonomous system number. So looks like we're receiving 65535, but we are, and let's go ahead and put in FFFF, and sure enough, that is 65535. And so that's why we're seeing that value on Gateway 2. It's actually telling us that peer is in the wrong autonomous system number. We're being sent FFFF, but clearly that's not the value that we have it set to. We have it set to 65, and let's change this here. 65335. Oh, it looks, let's clear that out. Sorry about that. Put the decimal value in first and get the conversion, 335. And actually it wants us to switch it. So we'll do 65335. There we go. And what does that convert to? So that would be FF37. And so do we see FF37 in here somewhere with this notification? I don't actually see FF37. But we've got these 2 bytes that we're receiving, and I keep trying to highlight it and it moves. And we can clearly see here that that's wrong. So we're in global config. Let's say router BGP 65000. Do show run section BGP. Let's make sure we get the right line. So no neighbor 209.165.201.6. And let's find out if this is in fact the root cause or if this is just maybe one of the faults here. So remote AS 65335. So we're going to remove that, and what we'll see is that the log messages are going to stop. We're no longer going to be receiving any of those log messages because we've removed that neighbor statement. So when I say do show IP BGP summary, right? And let's get that correct there. Do show IP BGP summary. I have a single iBGP peering with gateway 1. Let's take a look at, you could say do show BGP IPv4 unicast summary, which is sort of the address family way to approach things. But we see we don't have an adjacency with the internet router. So let's go ahead and set that up now. So we're going to go ahead and say, and I'm actually going to pull back the no 65535. And there we go. So let's resolve this issue and let's bring this back, bring the adjacency back up here, which should establish shortly. And then what we're going to do is we're going to test internet connectivity. And I believe the IP that we're testing to is a 209.165.201.225. So let's see right now through PC3. Can PC3 reach 209.165.201.225? So PC3 has no problem. Let's trace out to 209.165.201.225, and let's do numeric so that we don't have to wait for that extended period of time. And so you can see we go to 10.0.33.2, 10.0.10.26, and then out to 209.165.202. We reach our destination. So PC3 not having any problems. I avoided PC1 and 2 because those appear to be a part of a second trouble ticket. So let's do this. Let's shut down, show IP interface brief, and you can see here that this is 10.10.26, the Ethernet 03 interface, which was that interface facing the core routers, specifically router 1 and router 2. Both gateway 1 and 2 are using Ethernet 03 here. Ethernet 00 to the internet and 01 between each other, I believe, or it's 01 to the internet and 00 between each other. So we've got reachability from PC3. Let's come over here to gateway 1 and let's go into global config, interface range, and we'll say Ethernet 00, comma, or actually 0, 1, 2, and 3. So we're going to go into all 3 of those interfaces and we're going to say shut. So we're going to shut down, basically cutting router 1 off, or I should say gateway 1 off from internet and internal connectivity. But we've got this adjacency here. Let's say do show IP BGP summary, right? And you can see that this will eventually time out. But what happens if we go to PC3? Let's see if we're going to have to wait for that peering to clear out. So let's trace and let's see where we go. It looks like internally things haven't sorted out yet. So we're probably going to have to wait for the IGP to converge. And there we go. And it's going to take us out to our destination. So if we run this again, you can see that the BGP peering and the internal routing information has changed. So now we're not going to 10.0.10.26. We go to 10.0.10.22. And if I come over here to gateway 1 and I say, you can see the OSPF process timer died there. So the IGP reconverged, right? So getting us from PC3 up to router 2, where the original path, and so we'll do the original path was here, and then we basically took gateway 1 out of service, and then the new path, we'll go with green, the new path became this path, right? Because remember, we're running OSPF right in here, including this interface and that interface, right? We've got our IGP is OSPF. So once OSPF converged, we were able to come back up to gateway 2, and now we're able to get out. So let's go ahead and take a look at gateway 2 here and see, do show IP BGP summary. And you can see that it's still holding on to this. We may have to wait for the BGP timer to expire, which should be 180 seconds, could be up to 3 minutes. So, but we're good. We've got connectivity from PC3 when gateway 1 is out of service. So let's restore connectivity to gateway 1. We'll say no shut, bring those interfaces back online, and let's check the connectivity now. Let's trace out and see, do we go to 10.0.10.22? And we still do. We're going to wait for OSPF to come back online. You can see that the BGP adjacency came up, the OSPF adjacency came up, and so as soon as OSPF reconverges, and there we go, 10.0.10.26, which is taking us over to gateway 1. And this is the expected behavior. So it appears that that is going to be the only fault that we needed to address in order to bring up the connectivity when gateway 1 is offline. So that's going to take care of the first trouble ticket. And this is where I saw this classroom PCs 1 and PC2. They do not have internet connectivity. They cannot access the internet. So here we were given sort of a hint as to where we could start looking, right? Because we knew that gateway 1 was having issues. So now down here we know it's going to be PC1 and PC2. So let's go ahead. And we were fortunate enough to see those scrolling messages on the screen. I don't think we're going to see that with PC1 or PC2. So let's confirm the issue. Let's go ahead and say ping 209.165.201.225. Okay, so this is typically what we've seen. When we did the Sechnik activities, we saw this message when we were not receiving an IP address via DHCP. So let's take a look and say show IP interface brief. And sure enough, it looks like we're going to be getting our IP via DHCP. Show run interface Ethernet 00. And there's the command, IP address DHCP. So we know that PC1, and I'm going to make an assumption here that PC2 is going to be the same. Let's confirm the issue. Yep, and show IP interface brief, DHCP, show run interface Ethernet 00. And sure enough, we should be getting the address via DHCP, and we are not. Now, the interface shows up here. I believe it showed on PC1 up as well. So let's go ahead, go bottom up, right? We'll start with our layer 2 setup here. Let's come up to switch 1, and let's take a look at the physical ports here. Show IP interface brief, and all of these are up. So let's say show interface status. And we can see that we've got Ethernet 00 and 01 are trunks, and Ethernet 02 and 03 appear to be the VLAN 11 and 22 ports for PC1 and PC2. So let's confirm the VLAN is correct. So we'll come to the job aids. I believe the second VLAN diagram. So there we go. So PC1 into switch 1 VLAN 11, PC2 into switch 1 is VLAN 22. So the VLAN assignments are correct. Let's look at the ports here. 02 is 11. That's correct. 03 is 11, and that is also correct. So let's take a look and see what the VLAN shows. So show VLAN brief. Let's make sure. All right. So now this is interesting here. Excuse me. So Ethernet 03 doesn't show up anywhere in this output, and VLAN 11 is correct. So it appears that there may be no VLAN 22 configured. So let's say show run interface Ethernet 02. Aha, and we've got some additional information. Show run interface Ethernet 03. And what's interesting here is it says switch port access VLAN 22, switch port access VLAN 11, but when we looked at the VLANs, there is no VLAN 22. So let's go ahead and say VLAN 22, and we'll just give it a name PC2. Right? So now if I were to say do show VLAN brief, will we see that VLAN? No, we don't. Remember, we need to exit the VLAN configuration mode, do show VLAN brief, and now we see VLAN 22. So of concern is also what we saw on both of these port configurations. And this is sort of an immediate red flag when we see port security turned on. So remember, we need the switch port security command by itself, or else all of these other switch port security commands are null and void. And so this is one of the instances where the MAC address excuse me, is not being learned dynamically via the sticky method. It appears that what we're doing here is they've actually hard-coded the MAC address of PC1 and PC2 respectively. So let's go ahead and say, and let me get this back on here, do show port security, and let's see what we've got going on. So interestingly enough, the count is 0. Current address count is 1. The maximum number of addresses is 1. And so the security action is protect. And so it doesn't appear that the switch port security is causing an issue, but those MACs look really bizarre. 123F and then 124E. So let's do this. Let's say do show interface Ethernet 02. And let's see what we've got here. And how about a do show MAC address table? Oops, do show MAC address table, and let's see what we've got in here. All right, so 123F, because usually it's AA, BB, CC, and then something. So we've got a static, and this is where you'll see we have a static MAC address here, right? And we also have a static MAC address here, and that is also correct. So the MAC addresses appear to be correct. Let's go ahead and take a look. And oh, actually, hold on a second. So when you have static MAC entries that have been put in here via port security, that's the address that's going to show up. And so let me get on to PC1 and let's take a look. Show interface Ethernet 00. Okay, right, because it's typically, because I could not get by the fact that we typically see AABBCC00. So take a look at the address here for PC1. It is not 123F, and I'm assuming PC2 is probably show interface Ethernet 00 is also AABBCC00 5200. So PC1 is 5100, PC2 is 5200. So let's do this on switch 1. There's a couple ways we could solve this issue. I could say interface Ethernet 02, do show run interface Ethernet 02. And I could say no switch port security, MAC address 123 Fox, 123 Fox, 123 Fox. And what I could do is I could either hard code it again, and let's do that. Switch port security. We'll do it on this one here. MAC address is AABB.CC00.5100. Cannot convert dynamically secured address to configured address. Let's see what we've got here. So do show run, interface Ethernet 02. So it doesn't like that. So let's go with switch port security, MAC address, MAC address sticky. And let's see what we get if I shut the port down and then say no shut and bring that port back up. Let's see, do we learn do show run interface Ethernet 0, 2? And there we go. So now we've got that sticky entry in here. Let's go to PC1 and check. And let's see, show IP interface brief. Did PC1 pick up a DHCP address? Fantastic, it did. And do we have reachability 165.201.225 numeric? And we do. So let's go ahead and implement the same solution over here on interface Ethernet 03. So we had actually three things wrong, right? The switch port security MAC address statements on each of the 2 ports, and then we're missing VLAN 22. And so the bottom-up approach was, again, valuable, paid off here in the end. We're going to say do show run interface Ethernet 03, and then no switch port security MAC address 124E, 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 and we'll say switch port security MAC. And you know what? Hold on one second here. I'm concerned. Do show MAC address. That error we got before. So the static entry is still here. So interesting. And let me take a look at that port. Do show run interface Ethernet 03. I think it's interesting that it has that. So let's clear it. Let's say clear MAC address table. Whoops. And I want dynamic. And we'll do clear MAC address table dynamic. So now what I just did was I cleared these MAC address table entries, because the reason we couldn't put it in before when we did the 5100 for PC1 is because this looks like a static entry gets left behind here for the PC. So I cleared the MAC address table with the idea that what we're going to see here, show MAC address table, no, and it still has that static entry. So we'll go back in interface Ethernet 03 and switch port security MAC address sticky, and what we should see, and you know what, hold on a second, do show run interface Ethernet 02 and 03. All right. Yeah, so that's what we're going to do. Okay, I'm just double checking to make sure. And then let's shut down that interface, and we'll bring that interface back up. As soon as we get the message that it's been shut down, bring the interface back up, do show run interface Ethernet 03, and there we go. We've got our sticky entry in there. So now let's check on PC2. Can I get to, and we'll trace ourselves over to 165.201.225. Ah, I forgot the numeric. Let's get that in there. Make it a little quicker, and let's see, did we get an IP here on? There we go, okay. So it looks like we had to ARP out to get that layer 3 or layer 2 information. And now we've got it, and so there we go. We've got connectivity from PC1 and PC2 out to the internet. So 2 things we had to deal with, BGP, and then we also had to deal with the missing VLAN as well as port security in the first TINC Garbage Disposal Activity Challenge number 4. All right, so that is a review. And again, we used the bottom-up approach when we were dealing with the PCs, and then we were given a pretty glaring, not reminder, but a pretty glaring indication that there was definitely something wrong with BGP, and we got to see the hexadecimal, how we can see in hexadecimal the value that we're being passed as an autonomous system number. All right, guys, thanks for watching, and I'll see you on Thursday night.